Okay, welcome back again to another video. So in this video, we're going to talk about the Bayils-hilman reaction. So sorry about my pronunciation, like it should be Bayils, I guess. Let's move on. First, let's look at the reaction which we are trying to understand here, and then let's move on to the mechanism. Okay. Now let's say we have a phenyl group and then carbonyl group here and hydrogen. Now what you going to add is another molecule such as this. With, let's say, CN group. Now this CN, this group should be an electron withdrawing group, right? Here I'm going to put it here, this one. This should be a electron withdrawing group. Like bromine is also fine, they are electronegative atoms, so they can withdraw electrons. This should be an electron withdrawing group. Now we are going to put this under NR3s, or you can use PR3. These are you know what the R means, right? R are alkyl groups. Okay, CH2 CH3, likewise it can be a organic molecule. Now the product is this one. Here we have the pH group, we have the CN group, and we have, so don't get confused over here, right? This is not an oxygen, right? Like you may think when you are getting the note, when you get off the notes, then you are going to look at your notes when the exam is near, right? You may think you have Mr. Oxygen here. No, it's not. So please be aware of that. If you are that kind of person, like if you are taking the notes, like if you are remembering your notes when the exam is next day, right? So it's better to put a CH2 here, otherwise you will get confused. Trust me, you will, because I have done it also. So don't get confused here, right? So this is our reaction. Now let's see what's the mechanism here. Okay, let's look at the mechanism. Now let's take our electron withdrawing group and this alkene group. Okay, now here we have a CN. Now if you remember, we are going to add NR3. Now first step, what happens is we have NR3, it contains a lone pair. This lone pair will attack into this particular position. Due to this attacking, this bond will be shifted into this position. So we have talked about little like this mechanism. If you remember Michael addition, right? We have talked about it also. So if you are interesting, you can watch it here. I will put the link, the Michael addition. Okay, now let's move on here. Now with this attack, you can see our nitrogen atom is going to be attached to our original molecule. Now here we have the CN group here. Okay, sorry, I just made a mistake. This guy right here, this is not going to form the double bond here, right? It's moving towards here to form a lone pair. Here we have a lone pair, sorry about it. Here we have the nitrogen atom, it's a positive charge now. Okay, it's a positive charge now. Now what happens is, if you remember, we are using an aldehyde here. Okay, let's take the aldehyde. Now the aldehyde comes into action. You can see there's a nucleophile here. This carbon is electron deficient one, so it can go and attack to this carbon. Now what happens, we can form our molecules like this. Okay, let me draw it correctly. Okay, here we have the pH, and now due to this attack, right, you know, this bond has to be broken here. I'm going to draw that. Okay, now here I'm going to draw this carbon, and here we have NR3, here we have the CN. So let me number the carbon atoms. So unless if in case you get confused with it, let's put numbers for here. Let's pH is here. This is number 1 carbon. let's take number 2 carbon is this one, number 3 carbon is this one. Okay, so you know this is the number 1 carbon, here you have the number 2 carbon, and this is the number 3 carbon. Okay, you're okay with the CN group. Now what happens, this is our structure, you can see this is a positive charge. Now there's a hydrogen here. Normally there's a hydrogen here. Okay, normally there's a hydrogen here. What happens is this hydrogen is going to be removed to form a double bond between these carbon. Now you can see this carbon is getting destabilized, okay, because it's going to form a bond with this, so it has to lose another bond. What's the better one? This is a very good leaving group. You can see this is a positive charge, so this bond is easily broken back into the nitrogen. With that you can achieve, here we have the pH group, and still you have the oxygen containing negative charge. Cyanide is there. Now you have a double bond here, and NR3, this group has been left. It has been left. Okay, now here we have our molecule. Now what happens, if you remember, this is our molecule which is forming. This can be formed, this can be formed to form here, or otherwise you can go with the OH group here, right? You know, both are fine. The resonance structures, no? So yeah, let's put this bond over here to form the final product. This one. Okay, this is the mechanism for Bayils-hilman reaction. I hope you're okay with it. So this is a very simple reaction, right? It's not a big deal. It's a very simple reaction. Just familiar with the steps, you will see that the steps are the same. Like every mechanism contains this nucleophile attacking these carbonyl groups. Likewise, the same things. Only thing you need to do is just to memorize the steps, like the order of it, right? So draw this mechanism 1 or 2 times, then you will be fine with it.